So Bismillahirrahmanirrahim, Assalamu alaikum, and welcome to the lab number 6 of linear control systems. And this lab is about the block diagram reduction. And in this lab, you will learn to reduce multiple transfer functions into a single transfer function using the MATLAB tool. And you can ask your questions during the session using the chat box. Okay, so San कह रहे हैं कि message okay, assignment we will discuss that later. Okay, so let us start. So there can be multiple configurations of more than one transfer functions. So as you can see here, the two functions or the two transfer functions can be in series. Similarly, the two transfer functions can be in a parallel configuration, as you can see in this slide. They can be in a unity feedback system, which has multiple transfer functions and a feedback. And also these systems can be in a non-unity feedback configuration, in which there is also some transfer function in the feedback as well. So these are the four types of the feedback systems: the non-unity, plus unity, series, and parallel. These are the four basic configurations in which you will mostly get your transfer function, more than one transfer functions. So the first configuration we have is a series configuration, and as you can see that the two transfer function g1 and g2 are connected in series. U of s is the input and y of s is the output. Both of the blocks are just like they are multiplying each other. Okay, so in a series configuration, both the transfer function g1 and g2 are actually multiplying with each other. Okay, so I hope you can see the arrow. Okay, here's the arrow. Okay, so now what we need to do here, basically we need to implement these systems, this series configuration and this parallel configuration and so on using MATLAB. So the command over here for a series transfer function, multiple transfer function in series, is described here. SYS, which is actually your output, and we will be getting this output by a command which is called series, and in round brackets we will write system1 and system2. You can simply define this system as g1, g2, and by any other you can give name of any name to this variable, like a, b, c, d, but mostly the transfer functions are defined as g1 or g2 and so on. Okay, and the feedbacks are defined as h. So this is the SYS is actually the output, in which you will get the result of your configuration, and g1 is the first transfer function and g2 is the second. So both are connected in series. So this is the first example. As you can see that there are two transfer functions, with the first is g of cs. Okay, you can also call it g1, which is s plus 1 which has s plus 1 in the numerator and s plus 2 in the denominator, and the other one is g of s, which has 1 in its numerator and 500 s square in its denominator. So you can see the MATLAB code over here. So in the first line, in the first three lines actually, the first three lines, this transfer function has been defined. So as you can see that the numerator has 1, the denominator has a value of 500 s square, and then I have entered two zeros over here. So the first 0 is for s and the other 0 is for the constant. So it means that the denominator will be having some value of 500 s square plus 0s plus 0. So अजान पूछ रहे हैं कि ज़ीरो मस्त लगाना होगा. Yes, if you are not adding a 0 over here, so MATLAB will consider it as a constant. So if it is only 500 and you close the bracket, so MATLAB will consider this function, this transfer function, as 1 divided by 500 only. So you must have to add zeros for those quantities which are missing. Okay. So the first transfer function, first three lines are defining this. Then again we are using a command of tf to define the transfer function. We have used multiple commands before this to define transfer functions. We have used the one with symbolic variable. We have used also tf and in round brackets s. This time we will be using a simple command. This is the simplest of all, in which you just write tf, and in the round brackets you can define first your numerator and then your denominator. So the numerator and denominator which you have defined above will be saved in sysg. Okay, or you can also call it g1 as well. So it's up to you that what kind of variables you are using to define your system. Then in the next three lines I have defined the other transfer function, this one, the g of c. It has been defined here. First I have defined the numerator. S it is actually 1s here, then 1 which is here, then the denominator, it is actually 1s plus 2, so 1s and 2, and then in system H we have stored and we have applied the transfer function on numerator h and denominator h. So after defining both of these transfer functions, we can simply add the command of series. The final system will be equal to series of system G and system H, and here is the result, you can see. So let us try this on MATLAB. So I have opened a new editor file, which is actually a new M file, and I am going to define all of these. Okay, so here you can see that we have written the same code which was there in that example 1, and the result is also the same, which is s plus 1 divided by 500 s cubed plus 1000 s square. So this is how you will combine two or more functions in transfer functions in series. Okay, so I hope that first example is clear. Now we will go towards the parallel configuration. Okay, so for the parallel configuration, two systems, you can see over here that these systems are just like being added to one another. So G1 and G2, or you can simply call it G and H. So if both the systems are in the configuration, in the parallel configuration, so they are just like adding each other. Okay, so two transfer functions are going to be added with one another. So here's the code. As you can see that there is only one change here, that we have written parallel instead of series, and all the other parameters are same. We are going to save it in SYS, and system 1 and system 2 are to be written in the round brackets after the command of parallel. So now we have another example over here. In this example, both the systems are in parallel, and we have to get a single transfer function for both of these transfer functions. So this is the first and this is the second, as we have already defined it in MATLAB. So what we are going to do, we are just going to change this or add this command to the MATLAB code, and we will get the result. Okay, so I have already written this command over here in the MATLAB. So what I'm going to do, I'm just going to change or replace this series with a parallel function. Just click on run. Okay, so here you can see that both of the transfer functions are now just like we have added them, and the result is here, which is 500 s cubed plus 500 s square plus s plus 2, and then we have 500 s cube plus 1000 s square in denominator. Okay, so this is how you are going to configure, you are going to add multiple transfer functions in parallel configuration, connected in parallel, by using this command. Okay, moving towards the next example or next configuration, we have feedback configuration. So the first feedback configuration is a unity feedback system. So as you can see in the diagram that there can be one or more systems which we have defined, and in this block the multiple systems can be in series, can be in parallel, or in complex configuration, or it can be a single transfer function, and the feedback can be seen here. Okay, so this is the feedback, and it is called unity feedback because it has no transfer function in its feedback loop or the feedback path. So when there is no transfer function in your in the feedback loop, it means that it is a unity feedback. Okay, so here is the syntax for the unity feedback. So again, the system will be having your output. The feedback command will be used for configuring the systems in feedback. System 1 will be actually your transfer function which you have defined. It can be a single transfer function, or it can be multiple transfer functions in series and parallel configurations. And then we have one in round brackets. So this one actually shows that it is a unity feedback. And then we have sign. Okay, now in this sign we have +1 for positive feedback and we have -1 for negative feedback. As you can see in your diagram, if I can erase this. Okay. So the feedback can be a positive and it can be a negative. So if it is a plus over here, so you have to mention the +1. Actually you have to write +1 in your syntax, and if it has a minus over here, so you have to write -1. Okay, also you can see that the negative feedback, with the negative feedback we have written default. So default means that if you do not mention +1 or -1 in the sign column, in the sign instead of sign here, so what it will do, that it will consider every feedback as a negative feedback, because most of the feedbacks are negative feedbacks. And now this is the example. We can see that the two systems g of c and g of s, gc of s and g of s are in series. First of all, both of these systems are in series, and later on we have a feedback loop over here, and it is a negative feedback. So let us write this code in MATLAB. So in the first part of the code, what I have to do, I have to actually define the both of the transfer functions, gc of s and g of s. I have to define these transfer functions just like I did in the first and second example. So in the first three lines I have defined the transfer function 1 divided by 500 s square, and in the next three lines, line number 4, 5 and 6, what I have done, I have defined the other transfer function which has s plus 1 in numerator and s plus 2 in the denominator. So both of these are defined as system 1 and system 2. Next, what I am going to do, I have to configure both of these systems in series, because as you can see in the diagram, both of these systems are connected, these transfer functions actually are connected in series. So here you can see that system 3 will be equal to series system 1 and system 2, and in the end you have to apply the feedback to this system. So as you can see the code for feedback, I can zoom it in here. So you can see first of all we have written feedback, then our system for feedback is system 3, and then there is 1 in square brackets, which means that it is a unity feedback, and then we have written -1 for a negative feedback. As you can see in your diagram that the feedback is a negative feedback. So let us execute this code. Okay, I will also clear the screen because there are multiple codes now. I'll just clear the screen so you can see one code at a time. So you can see here, first of all, both of the transfer functions are are configured in series, and after that we are having the result, which is actually the with this feedback. Now I have as I told you earlier that we have multiple configurations for a feedback. It can be a positive feedback and it can be a negative feedback. Okay, so what we can do here is we can change this sign with this plus. We can write +1 or we can write -1 for the different types of feedback, but here we have a negative feedback, so we have written -1. So as I told you that the negative feedback is actually the default configuration for most of the feedbacks. So if I don't write -1 over here and simply I define it as feedback system 3 and square brackets 1, the result will be same. Okay, so let me define it as system 4, and let's see what is the result. Okay, and I will also add the command for system. Okay, Azan, आपका क्वेश्चन भी हम अभी लेते हैं. Let me just complete this part. Let us look at system 4 and system 5. Okay, and here we go. So in system 4 I have defined the feedback configuration, and I have added -1 over here. And for the system 5 I have skipped that -1, I have removed that, and let us see that is there any difference in the result or it is same. So I have executed this code, and now you can see that system 4 and system 5 both have similar values. So if you add a -1, or if you just skip that -1 in the end for a negative feedback, it won't affect your output or your result. ओके, सो अजान का क्वेश्चन है कि सर हम न्यूमरेटर एंड डिनोमिनेटर को एक वेरिएबल में भी डिफाइन कर सकते हैं. नो, आई डोंट थिंक अगर सेपरेटली आप कर रहे हैं, ठीक है. आई थिंक कि आप कहना चाह रहे हैं कि अगर हम इसको लिख दें 1 डिवाइडेड बाय, ओके, सो यू मीन टू से दैट अगर हम इसको ऐसे लिख दें कि 1 इन राउंड ब्रैकेट्स, सो जस्ट हम इसको अगर रिमूव करके हम लिखें न्यूमरेटर, ओके, सो न्यूमरेटर या हम इसको सिर्फ अगर डिफाइन कर दें G1 is equal to 1 and divided by 500 0, okay, so we have to add square brackets 500 0 and 0. I'm trying it कि अगर ये होगा या नहीं. एंड देन हम G1 को ऐसे ले लें. सो लेट्स ट्राई. जो जान कह रहे हैं कि अगर हम इस तरह कर सकें कि G1 इज इक्वल टू 1 डिवाइड बाई 500. ओके, सो ये नहीं हो सकता फ़िलहाल. सो दिस कॉन्फ़िगरेशन इज़ नॉट वैलिड. ओके, सो अगर कोई और आपके माइंड में कुछ और हो, अगर देखें जो हमने लास्ट टाइम किया था, अगर आपने इसको इस तरह डिफ़ाइन करना है कि 1 and then you have to define 500 and 0 0. So you have to add the command of Gigi, you can open your mic Azan. अच्छा अच्छा, ठीक है ठीक है. सो ओके, सो इफ़, अच्छा, अगर आप मुझे बता दें अजान के 1 मैंने लिख दिया है, ठीक है. ऐसे स्क्वायर ब्रैकेट में क्लोज कर दें जी, ठीक है. अच्छा जी, ठीक है जी. अच्छा जी, यहाँ पे कॉमा डाल देते हैं और फिर इसको डिफाइन कर देते हैं, ठीक है. और फ़िलहाल इसको हटा देते हैं. अच्छा जी, ठीक है. अच्छा जी हाँ, ये नहीं हुआ. सो यू बिल्कुल आपने सिंपली, अगर इफ़ यू वांट टू डिफ़ाइन इट, तो आपने इसको डिफ़ाइन करना होगा जिस तरह हमने लास्ट इस एग्जांपल में किया था कि 1 डिवाइडेड बाय 500 s स्क्वेयर. ओके, एंड सिंपली आप यहाँ पे इसको डिफ़ाइन कर देंगे और फिर आप लिखेंगे TF sys is equal to TFS. ओके, सो फिर ये इसको उठा लेगा. ओके, ये इस तरह हो जाएगा. ओके, सो अभी भी नहीं हो रहा, ठीक है. TF के हमने करना है इसके अंदर. सो आई थिंक जो हमारे पास S is equal to TFS. Okay, so it's not valid. Let me try one more. Okay. ओके, तो इस तरह हो सकता है जान, अगर आप देखें, इफ़ यू वांट टू डिफाइन इट, सो फर्स्ट ऑफ ऑल यू हैव टू डिफाइन द एस टी एफ एस, जिस तरह हमने लास्ट फर्स्ट ऑर्डर सिस्टम के लिए किया था. देन G1 में आप डिफाइन कर दें 1 डिवाइड बाय 500 एस स्क्वेयर, एंड देन यू कैन डिफाइन G2 इज इक्वल टू 1 प्लस S and S plus 1 and S plus 2. Sorry. So this is S plus 1 and divided by S plus 2. And then you can write G is equal to series of G1 and G2. So this is another configuration जिससे आप इसको कर सकते हैं, जो हमने लास्ट लैब में भी हमने जो कमांड यूज़ की थी, S इज़ इक्वल टू TFS, और फिर अगर हम G1 में G1 को फिर हम डिफ़ाइन कर देते हैं सिंपली, एंड G2 को डिफ़ाइन कर देते हैं, और फिर सीरीज G1 G2, एंड यू कैन आल्सो ऐड पैरेलल ओवर हियर. So this is another way you can do this, define these transfer functions. Okay, Azan. Okay, ठीक है जी. So different तरीके हो सकते हैं. There can be multiple ways you can define your transfer function, and जिस तरह हम करते आ रहे हैं from the last few labs, जितनी भी labs हमने की हैं, so we have seen different ways of defining transfer functions. So you can use any of them, as long as your code is executed properly and you are getting your results properly. So now we come towards the last example of our today's lab, in which we have a non-unity feedback system, and in this we have multiple transfer functions. So first transfer function, system1 g of s, it can be a combination of more than one transfer functions. And then in the feedback, which is h of s, again we can have a single transfer function, or we can have a combination of multiple transfer functions in this g of h, system h of s. And also this this feedback can be a positive or a negative. Okay. So this is the command. First of all, we have a command of feedback, and then we have system1 and system2. Just like last time, in the last example, what we were having there was simply a system. If I can go all the way back, there was simply this command of feedback, system1, and then for the feedback we had 1 in square brackets. But here we have system1, which is actually the system g of s, and then we have system2, which is at the h of s. So system2 here is representing the transfer function in feedback, and then the sign +1 for positive feedback and -1 for negative, or you can just skip for negative feedback. Okay, so here's our code. So again, in the first 3 lines, I have defined the first transfer function. In the next 3 lines, I have defined the transfer function in the feedback. and in the last line I have to find system feedback system 1 system 2. I can add comma -1 here, or I can simply skip this -1 and I can write simply system 1 and system 2. You can also write it as system G and system H if you want to remember that it is the system G is actually the transfer function and system H is actually your feedback. So you can write system G and system H. So just execute this code and you will get the result over here. Okay, so these were the 4 configurations, and now I'm going to explain you the lab task. Okay, so this is lab task number 6 to obtain transfer function of a system using block diagram reduction. So I'll just zoom it in for you people. Okay, so in 6.1 we have given a transfer function, 2 transfer functions which are actually in series configuration, and this is just similar to example 6.1. What you have to do here, you have to write your ID, complete ID with S square, just like we had 500 S square there. You have to write your ID over here. And also you all can open your mics and ask me questions if you have any questions. Then in 6.2 we have a again we have a transfer function. Multiple transfer functions are in parallel configuration, and in the denominator of the g of s you have to write your ID and S square. Okay, then 6.3 we have a unity feedback system, and again the change is just your ID over here. And 6.4 is similar to example 4 with a non-unity feedback system. Okay, then in 6.5 we have a complex system in which we have multiple feedbacks and multiple systems are connected in series and parallel configurations. So what you have to do, that you have to solve this system. I have given G1, G2, G3, G4, H1, H2, H3. So the values are given, and first of all you have to define these values in MATLAB. You have to initialize these values, and then you have to configure them in series and parallel and feedback configuration. So this one is a lot tougher than as compared to 6.1, 2, 3 and 4, but 6.5 is a bit a challenge for you people. So let's see will you guys will be able to solve it or not. Okay, so अब हम questions लेंगे. अगर questions हैं तो